this is Navya Marineni. In this video, I am demonstrating my applied project AgroVision, which is a smart irrigation decision support system. So the purpose of AgroVision is support better irrigation decisions using environmental data such as soil moisture, temperature, humidity, rainfall, and wind speed. Instead of depending only on fixed schedules or like guesswork, the system uses predictive logic and dashboard to generate more data-driven irrigation recommendation. Now I will show how I design my dashboard demo. So let me open the VS Code first. Yes, here it is. Already I started my AgroVision dashboard. So once again I will show here. So I will go to my project folder first, AgroVision. Then I will run streamlight run app.main.py. So it will take me to the dashboard page. So this is my user interface of the dashboard. So at the top I have the main dashboard header. On the left I have the upload session on the rainfall override controls. So first I have simulated data that I created. So I will start it by uploading the CSV file that contains environmental input data for the system. This data set includes the variables the system uses, like soil moisture, air temperature, humidity, rainfall, wind speed, soil type, and crop stage. So I am uploading it. So once the file uploaded, the dashboard start displaying summary information. Here you can see the difference. So at the top of the dashboard, these KPI cards provides a quick summary of the uploaded data. So here I can see average temperature, average moisture, average wind speed, and average humidity. So below that I can see the dashboard's environmental trends. This graph visualize how the environmental variables behave across the uploaded records. Here at 199, soil moisturizer is 12.23, air temperature 17.66, and humidity 45.07. So here we can see at 310, here we can see at 508. Like that we can observe. So when I go to recommendation section here, this is the irrigation recommendation engine. I can see here the system allows me to select the specific row from the data set for the prediction. Here we can see we have this much of rows. So here I didn't selected anyone, so it took overall summary of the record. So this is what overall summary of the record. So I'm randomly selecting one row from the data set. So it is 120. So this summary clearly shows the exact values being used for prediction, including soil moisture, temperature, humidity, rainfall, wind speed, soil type, crop stage, and mode. So then now I'll click on generate recommendation. So system can predict the irrigation need for this 120 row record. So I'm clicking the generated recommendation. Now the system has generated the recommendation. Here AgroVision shows the recommendation in clear decision support format. it gives the recommendation status, uh, the predicted irrigation needs per acre, and a short explanation based on the environmental condition. So instead of only showing a raw model output, the dashboards translate the result into something that easier for user to understand. So we can see here high irrigation required. Recommendation is influenced by low moisture, low rainfall, high temperature. So this is what baseline prediction is shown. Here is the it clearly showing baseline prediction is shown. A turn on rainfall override to compare what if scenario. Okay. So on the right side, the system also shows baseline, adjusted, and difference values. This becomes especially useful when I apply a scenario change. Okay. Such as modifying scenario change. Modifying rainfall. When showing rainfall oversight, one of the practical features of AgroVision is this rainfall override in the sidebar. Okay, this allows the user to simulate a what if condition. So let me talk about the example here. If rainfall changes, I can update that value and then generate the recommendation to see how the irrigation need changes. So now I have applied the rainfall override. So I'm guessing it is 4.0 and apply rainfall override for the prediction. Okay, so this is what. Now the dashboard recalculate the adjusted the prediction using the real rainfall value. So I'm clicking generate. Here you can see the different rainfall override is active. I just click the 4.50. If I click it is 11.0, then I'm again clicking on generate. Here you can see at the bottom scenario comparison charts are shown, the baseline and the adjusted prediction side by side. This value comparison makes it easier to understand how the system responds when rainfall conditions change. So overall the dashboard demonstrate how AgroVision combines environmental monitoring, prediction, scenario based recommendations support into one smart irrigation prototype. This is how it works. Thank you.